concrete has cured and I'm ready to attach the bearers. First I need to cut the piles to height. The Mitek Pile connectors I'm using need a chamfer cut on one side of the pile. The pile is 125mm wide and the bearer is only 90mm wide, and the chamfer allows the nail plate to sit flat across both faces. I use a circular saw to start the angle cut, and then I finish off with a handsaw. The Japanese pull saw makes short work of it. I prefer the ergonomics of the pull stroke, and this saw has dual edges, one set of teeth for cross cutting and the other for ripping along the grain. Using the blade made for ripping is a noticeably different experience. Any cut ends, notches and holes in timber piles need preservative applied. I'm using a liberal application of Metal X. I built this 76 square metre timber framed house in 2020, and I'm showing you how I did it stage by stage, from set out, the timber floor, walls and roof framing, through to the weatherboard cladding and more. I've left most of the pile bracing in place. Timber exposed to the sun will start to move, and I want these piles to stay square while I work. To get my process set up, I'm starting with the shortest bearer. This bearer does support floor joists, but its primary function is carrying the load of a structural wall above it. Instead of measuring across the piles, it was easier to set a length on top, check the overhang at one end, then mark the overhang at the other end and cut it. I then use it to mark the second length. I use bugle batten screws to prefix the links together. They work well to pull the links in tight if they aren't fully flat or straight. I then nail off using the NZS 3604 requirements for built-up members, spacing the nails no more than 6 times the thickness of the timber. For these 140 by 45mm lengths, that's 2 rows of nails every 270mm, driven from alternating sides. When selecting the timber for bearers, you don't have to use a single solid piece. A 90mm thick bearer can be one length of 90mm timber, or it can be built up from 2 lengths of 45mm thick timber. The 45mm thick timber is more readily available, so it's a more practical option for our builds. The same process and method applies to longer runs, but because I use more than one length per run, each length butts together and is joined on top of a pile. These joins also need to be staggered. Timber frame floors also need to be braced to prevent lateral movement. The height of this floor means I need to use braces that span from pile to pile. The layout for the braces has been specified by the designer, so all I have to do is check the layout works, making sure that there's no clashes in brace placement, and then I can make a start. I measure and I tack a nail in the bolt hole location on each pile. I can then hook my tape on the nail and measure the distance to the opposite pile. I mark those dimensions on the braces, pre-drill the holes, and I cut the braces to length. When drilling, I use 2 square blocks to keep the drill square. The hole in the brace then becomes my guide for a square hole into the pile. An important thing to remember when using stainless steel bolts is to apply anti-seize to the threads before assembly to prevent galling. The increasing friction as you tighten can cause the nut to bind. It feels like it's tightening, but everything is still loose. What's happening is the friction breaks down the protective oxide layer on the threads and the bare metal surfaces weld together. I'm using CRC nickel anti-seize, nickel based, so it's compatible with stainless steel. It prevents that direct metal to metal contact. That completes the bearers and bracing. The piles are now locked in, and in the next episode I install the floor joists and the sheet flooring to complete the floor build. Thank you for watching, and welcome to all the new subscribers. I appreciate the feedback I've received as I gradually refine the series in style in preparation for the next series, my own house build. See you on the next one.